Hello everyone, this is Mr. Anderson. We're going to spend a little bit of time right now going over how to run regression analysis based on two sets of numerical data. We have data from a cell phone company. X describes the monthly bill of the customer, and Y describes the level of satisfaction that customer experiences. Step number one in this math process is to make a scatter plot. You can see that I've already done that. And the scatter plot is important as a simple math process. It shows a trend in the data. You can see that we are experiencing a downward trend, a negative correlation as one variable increases, the other one is decreasing. That's why it's important to have a scatter plot. It allows us to make maybe an educated guess about what our data is saying. Step two is to go ahead and calculate that product moment correlation coefficient. And in order to do so, we need to run the 2var stats. We got to enter this stuff into our calculator. So you're going to enter the x data into L1, you're going to run the y data into L2, and you're going to run 2var stats. And doing so allows you to quickly find your x bar and your y bar, or your mean of the monthly bill. This works out to be $50.4 or $50.40, and your mean satisfaction level turns out that is 5. Okay, the next thing that we are going to be doing here is we're going to be copying our data into the table and finding the sum of the products. So we have 28 and 37, and we have 45, and then we have 63 and 79, 8 and 7 and 5 and 3 and 2. And now it's just a little bit of quick math on the home screen of your calculator. So for example, 28 times 8, that works out to be, and I'm going to zoom in here, excuse me. That works out to be 224. And then we got 37 times 7. And I know you guys can't see my calculator right now, but I have a calculator right next to the computer here that I'm working this out on. 45 times 5 is 225. And then we have 63 times 3. That works out to be 189. And then 79 times 2, that's 158. Now, the last step, you can see down here that we have the sum. So we're going to go ahead and take the sum of all these items. So 224 plus 259 plus 225 plus 189 plus 158. Add all those guys together, and I get 1,055. Okay, so I've come up with that sum, and now that's given me this piece right here of my formula. So in order to work out the covariance, then the covariance S sub xy. Apologize here, ladies and gentlemen, I'm having a little trouble writing. S sub xy equals the sum of that data, 1055. Divided by n, which is the number of data pieces I have. So I have 5 customers that I've collected their bill information and satisfaction level. So n is 5, and then I'm subtracting the x bar, the product of the x bar and y bar. So that's going to be 50.4 times 5. And I'm really sorry, I'm again struggling to do some writing here. There we go. Okay, now this is just a simple calculator evaluation, so we'll type this in, and we can type it in exactly as I've written it. And this works out to be, I got negative 41. S sub x y equals negative 41. There we go. Okay, on to the next step, right? So we're going to take this, we're going to go on to our next page. When you're ready, you can obviously pause the video at any time if you need to. Next page, we're going to take this data and we're going to use it in conjunction with the standard deviations to calculate that R value. So one more time, we need to copy some data. So I'm going to copy only my X data right now, all right, because I'm going to find the standard deviation with respect to X. So 28 and 37 and 45 and 63 and 79. Now, the next column is x minus x bar. That's going to be each individual x value minus that average of the x's. So, for example, I'm going to take 28 and subtract 50.4. And when I do that, I get negative 22.4. Then I take 37, I subtract 50.4. I get negative 13.4. I'm going to continue doing this. And I have all of those calculations made. Now it's simply take all of these values and square them. So negative 22.4, and I'll square that number. I get 501. Oops, excuse me. 501.76. Negative 13.6 squared is 184.96. Remember, anytime you square a negative, you get a positive, so 29.16 is 5.4 squared. And then I get 158.76, and then 28.6 squared is 817.96. And now one more time, we see that summation symbol, so that's telling me to add all of those items up. So give me just a moment and I'll have that for us. I got 1692.6. All right, now, unfortunately for us, that is not our standard deviation. So what I'm going to do here is I'm going to go ahead and take that value and I'm going to do just a couple more items. So S sub x, the standard deviation of our sample data, is equal to the square root of that sum, 1692.6, divided by n again, which in this case is 5. We got 5 pieces of data. So I'll work this out on my calculator. When I did this, I got the standard deviation is about equal to, and this is going to be money, so we'll say $18.40. Okay, so there's our S sub x. All right, now we're going to do the exact same thing with the Y data. This data should be a little bit easier to work with because it's much smaller. So the Y data, one more time, is, let's see, 8 and 7 and 5 and 3 and 2. And if you're wondering where that's coming from, I'm just copying that off of the prior page. So then it's going to be y minus y bar. And remember, our y bar is 5, so 8 minus 5 is 3. 7 minus 5 is 2. 5 minus 5 is 0. 3 minus 5 is negative 2, and 2 minus 5 is negative 3. Now the squaring. In this case, the squaring is pretty simple. I think everybody probably can take all those values and square them. And now I need to add them up, and if I take and add all those items up, I get 26. And now we're doing the exact same process I did above in blue, but it's S sub y, the standard deviation of our y data. So I'm going to take the square root of that sum, 26, divided by 5. Again, I'm dealing with 5 pieces of data. So it's going to be, in this case, the square root of 26 fifths, or 26 divided by 5. On my calculator to 3 sig figs, I get about equal to 2.28. Okay, there is the important information. We're now going to take this covariance data, we're going to take the standard deviation data, and we're going to go ahead and we are plugging that stuff in for our values. So that's what I'm going to do right here in step E. So R is equal to the covariance. Now give me just one moment. I got to look back at my notes on the previous page and try to remember what that data was. Let's see. I got 1055 for, no, excuse me. I really do have to back up. Just one more. All right, I found it. It is negative 41 from the previous page. So negative 41 goes on top. Then on the bottom, I just need to make sure I multiply before I do this division. So up above up here, the standard deviation with respect to x was $18.40. So this is going to be 1840 times the standard deviation with respect to y, 2.28, and a quick calculator calculation. will give me an answer, I hope. And I made a tiny error and a tiny typo in my calculator here. There we go. So I got about equal to negative 0.977. Ladies and gentlemen, what is that, right? This is the and explain what it means part. This is something that tells me I have a strong negative correlation. Okay, meaning that there is a strong relationship that that exists between the amount somebody pays for their bill and their level of satisfaction. Okay, next, because we have a strong negative correlation, step 3 is appropriate. Calculate our our regression model. Okay, so we're going to go ahead and calculate this, and we're going to check it. So it's going to be y minus y bar, and y bar in this case was 5, is equal to that covariance, negative 41, divided by s sub x squared. That's going to be 18.4 squared times x minus x bar. And x bar, let's see if I can look this up. X bar was 50.4. Okay, now it's just a little tiny bit of math. Y minus y bar, let's simplify that. Negative 41 divided by 18.4 squared. That works out to be negative 0.121 times x minus 50.4. And now we just distribute, so that's going to be y minus 5 is equal to negative 0.121x. I got to multiply negative 0.121 times negative 50.4, and I got positive 6.10, and now we just need to add 5 to both sides. So my model is going to look like this. Y is equal to negative 0.121x plus 11.1. All right, last thing I'm going to do is I'm going to check using stat and calc over to option 4, and it looks pretty stinking close there. So now the last thing, we're going to go ahead and make a prediction. Use it to make a prediction about an x value within the data provided. So for example, a person with a monthly bill, I want to interpolate here, so I'm going to pick something, a known value. I'm going to say something like $50. All right, and I'm just simply going to plug that in for x, and I'll say y is equal to negative 0.121 times 50 plus 11.1. All right, and we'll work that out. Let's see, I didn't mean to throw that last parenthesis on the end. All right, so one last quick calculation. And this is about equal to 5.05, and so the predicted satisfaction rating of that person would be about a 5. There you go. There's your regression analysis review, and remember, you can watch this video as many times as you need, or you can see me with questions. Thanks, and have a great day.